wabarakatuh, and good afternoon, everyone. Can you all hear me?
Yes, madam.
Yes, madam.
Right, okay. Okay, so I hope everyone is fine. Okay, and today is our last session for lecture, but we still have another session on Thursday, all right, to discuss some of the tutorial questions, perhaps, for chapter 5. Okay, I will talk about final exam afterwards. Okay, but first, I think I would like to continue with our lesson just to finish off our last section for vectors, which is about cross product today. Okay, anyone got any questions beforehand before I start? Anybody got any question to ask? Okay, let me just share the content. Okay, just to recap whatever that we have learned last week. Okay, we talk about one type of vector multiplication, which is about dot product. Okay, so we said that dot product is also called as scalar product because the product itself is a number. Okay, and we talk about the notation. All right, this is the notation for the dot product. Okay, where you have a dot in the middle. Okay, and for vector multiplication, basically you will have two vectors. Okay, two non-parallel vectors, all right, which their initial point coincide. Okay, so then for dot product, okay, what happened? Okay, what happened to my slide? Can you all see the slide? Okay, let me just share again. Okay, let me just share again. I think something is wrong here. Runiza starting to share content. Runiza. Runiza. Okay. Okay, all right. Let me just share again. All right, okay. Okay, back to our dot product. So again, as I mentioned, the dot product basically is a vector multiplication in which you will have like two non-parallel vectors in which their initial point coincide. And for these two vectors, they make a certain angle in between. Okay, and we have looked at in terms of how we actually find dot product in terms of its component. Okay, so basically, it's not that difficult. You will just need to multiply and sum. Okay, add, multiply and add. All right, those numbers. Okay, those components vectors, and then your answer will be a scalar number. So that is how we do dot product from components. Okay, and also because we said that there's a angle in between, so there's a theorem, okay, which also can sometimes we call it as a definition of dot product, or in terms of finding angle. Okay, so if question asks you to find certain angle, so you have actually this theorem, all right, which tells you that cosine theta equals to u dot v divided by the magnitude of vector u times magnitude of vector v. Okay, so then if question asks you to find angle, okay, angle between two vectors, okay, then this is actually is one way that you can actually use to find angle, okay, using what we call the dot product. Okay, and that is one concept, one important concept, okay, when it comes to angle between two vectors. All right, we talk about what we call orthogonal vector. So this is actually is a very important concept when it comes to dot product. Okay, in which that if we said that two vectors are orthogonal vectors or perpendicular to each other, then either we say that the dot product equals 0, or you can say that the angle theta equals to 90 degrees. Okay, so basically when theta is 90 degrees, all right, then we have these two vectors perpendicular or orthogonal, or what we call orthogonal vectors. Okay, so we also have a certain example last week, okay, in which how do you actually verify? Okay, how do you actually verify or determine whether two given vectors are orthogonal vectors or not? Okay, it's actually by finding its dot product. So if the dot product for those two vectors equal to 0, then you will say that those two vectors are orthogonal vectors or vectors perpendicular to each other. Okay, if the dot product is not equal 0, okay, then we say that those two vectors are not orthogonal vectors. Okay, and based on the definition earlier also in terms of angle cosine theta, so we also have concept of what we call direction angles. Okay, direction angles or direction cosine. Okay, so direction angles or direction cosine. Okay, so basically direction angles are the alpha, beta, gamma, and those angle alpha, beta, gamma basically are angles that is formed, okay, between a given vector, position vector, all right, and the positive x, y, and z axis respectively. Okay, so if we talk about three-dimensional coordinate system, so we will have, okay, then we will have these three direction angles or direction cosine. Okay, however, if we are talking about two-dimensional coordinate system, then we only have two direction angles, namely alpha and beta. All right, and in terms of theorem or definition for the direction cosine, okay, you have this type of theorem, okay, where you have like cosine alpha equals to the first component, okay, first component of the given vector divided by the magnitude of the vector. Okay, so basically this okay, what we call direction cosine or direction angle. So if we want to find direction angle, basically we just solve for alpha, beta, gamma. All right. Okay, so today what we are going to do is we are going to proceed. Okay, we are going to continue with another type of vector multiplication. Okay, so this is actually another type of vector multiplication. Okay, so in which what we call cross product. This is another type of vector multiplication. Okay, in which what we call cross product. Okay, so why is it named by the cross product? One thing, the word cross because of the notation itself. Okay, the notation. So if you say that two vector you want to find its cross product, the notation would be like u cross v. So that is the notation. Okay, cross. So that's why they call it cross product. And another name for cross product that you may encounter is what they call vector product. Okay, so that is also another name, okay, that you might actually perhaps come across, okay, in which what they call vector product. So why is it called vector product? Because the product itself is a vector. Okay, so cross product, the product is a vector. Okay, so that's why it is called vector product. So hence, if you talk about cross product, because the product is a vector, so therefore the product has a direction, okay, because it is a vector. So when it is a vector, there is a direction. And of course, you can also find its magnitude, okay? Because a vector, we know that it has a direction as well as magnitude. Okay, so basically in terms of geometric illustration, okay, geometric illustration for cross product, okay, in which you still have two non-parallel vectors. So that means you have like two non-parallel vectors, namely your vector u and perhaps your vector v. And these two vectors also, their initial point coincide, okay, their initial point coincide. But when we said that the product is a vector, it is actually is a vector pointing upward like this. Okay, so that is like u cross v. All right, we said. So it is actually is a vector pointing upward direction, or it can be pointing downward direction. If it is downward direction, then you are actually using the, instead of u cross v, then it will be v cross u. Okay, and I have actually later on I will show you a diagram, okay, of this geometric illustration using what they call using right hand rule. Okay, right hand rule. okay, where you will put your your hand on your vector u, and then you curl your fingers, all right, like going to the vector v, you curl your fingers, and then your thumb is actually pointing the direction of the cross product u cross v. Okay, so that is actually, it's a geometric illustration, all right, when we talk about cross product. So I will show you later on the another illustration or another diagram. Okay, but to proceed, then let's look at how we actually find a cross product using components. Okay, so basically, if you look at this definition, all right, look at this all right, this illustration here, this method or this process. Okay, if you look at this process here or this method, okay, perhaps it does ring a bell to you. What does this looks like? Anyone? What does this look? What does this look like to you? Okay,
It's a
it's a what?
Metric.
Okay, it's in a
Metric.
matrix. Okay, it is in a matrix form, correct? It is in a matrix form. Okay, like in this one, you can see it's a 3x3 matrix. Okay, and then what about this notation here? What is that notation last time? What does that notation stands for last time? What does it mean? Remember? In chapter 1, matrix, what does that notation mean?
cofactor.
Determinant.
Yeah, determinant. Yes, using cofactor,
Yes.
you said. Okay, but it's actually is a determinant. Determinant, correct. So basically, finding cross product is actually is finding determinant. Okay, it's finding determinant. Okay, and then one more thing that I forgot to mention, that that cross product is actually is only deal in vectors in three-dimensional space. Only three-dimensional space vector, not two-dimensional. Okay, because basically, all right, when it comes to cross product, you will have like another vector pointing. So basically, there are like three vectors involved. So all right, with the same initial point, you will have like three vectors. So basically, for cross product, okay, it only makes sense in the three-dimensional space, so not in two-dimensional space. Okay, so that's why when you look at this cross product here, the way you actually cross or find this product, basically using like 3x3 determinant. Okay, 3x3 determinant. Okay, in which, all right, in which if let's say you are given vector u has this component, all right, u1, u2, u3, and vector v has this component v1, v2, v3. So if let's say question asks you for u cross v vector, okay, u cross v, okay, so when you set up your 3x3 determinant, all right, the first row, you are going to put your unit vector ijk. This is unit vector ijk. That will always be on the first row. Then only the second row will be components for vector u, because you have u first here, u cross v, so u comes first, then only v. So therefore, the second row, you will put your component for vector u. Then the last row, you will put your components for vector v. Okay, all right. So basically, what you have is actually is a setup of like 3x3 determinant. And in fact, to find cross product is exactly the same as finding determinant of 3x3. Okay, determinant of 3x3, but using or by selecting the first row. You are selecting the first row. Okay, you select, because you remember in chapter 1 when we talk about determinant of 3x3, all right, you can select any row or any column. Okay, any row or any column, because in matrices you have all 9 elements are all numbers. Okay, however, when it comes to this cross product, your first row actually deals with unit vector. Okay, your unit vector ijk. So that means, for cross product, basically it is the same as finding determinant of 3x3 by selecting the first row. So you select your first row, okay, ijk. Okay, and another thing is that, all right, it is actually is similar, that you have a sign, plus minus sign. all right, for your first row. So if you recall last time, you will have your plus minus plus, isn't it? Okay, so that's the sign. So you will have that sign plus minus plus. Okay, because of remember a factor of -1 to power I plus j last time. Okay, I plus j. So that will give you plus minus sign. Okay, all right. So in this case, to find cross product is the same as finding determinant by selecting the first row. Okay, so you select your first row I, j, k. So then when you select your first row I, okay, so you will put your I here, positive I, followed by determinant. Okay, actually it doesn't matter. You can put your I in front. Okay, you can put your I in front of the this minor. Okay, however, because this is just a unit vector, eventually you will always write in terms of 2i, 3i, or -5i. You don't say I 3i 4. Okay, so we say 4i 3i. So that's why we will put I, behind your minor of this determinant. Okay, all right. But then again, back to this one. So you by selecting the first row. Okay, so then you will have your I here, positive I, and then followed by determinant of your minor 2 by 2. Okay, so minor 2 by 2, that means you just need to cover or delete your first column, your I column. So if it is matrix last time, we say we delete first row, first column. But in this case, our first row is just our unit vector. So it doesn't affect anything. So basically, you just need to cover your column only. Okay, your I column, then you have your U2, U3, V2, V3 as your minor here. Okay, your 2 by 2 determinant. Okay, there's a typo here. Okay, that followed by, this is not plus. Actually, this is actually minus. Okay, because it is a minus j. Okay, minus j. Okay, so then again, then minus j. So you have your minus. Okay, minus j. Okay, followed by this determinant. So this determinant is, you got it when you cover your column J. So when you cover your column J, what you have is actually is U1, U3, V1, V3. So that is here. And then lastly, followed by plus K, okay, plus K, and then times with determinant of this 2 by 2. This 2 by 2 components here, you got it when you just need to delete the last column, that is column K. So then you have your U1, U2, V1, V2. And then after that, it is actually finding determinant of 2 by 2. So when it is finding determinant of 2 by 2, again, make sure you do it correctly. It will be a product of a main diagonal minus with product of these two components. Okay? Okay, so it's a product of main diagonal, subtract with product of these two entries or two components here. Similar to here as well. That's how we find determinant of 2 by 2. Okay, so basically it is actually similar to what you have done, okay, in your determinant of 3 by 3. It's just that for this cross product, basically you are finding like determinant by selecting the first row, okay, of your 3 by 3 matrix. Okay, so again, mind you that for such procedure, the tendency is always making mistake in terms of plus minus sign. Plus minus sign, especially when it comes to this j component here, because you have a minus here. So there's always a tendency of making mistake with the sign inside, especially when you have minus and then suddenly inside here you also have minus. All right, so then you forgot to actually multiply by this. So it is important that you must put a bracket. Okay, you must put a bracket. If not, then you might actually get confused or you might actually get wrong answer. Okay, and another thing that I would like to remind you, that make sure you multiply your main diagonal first, then only subtract product of this. Okay, so you have done this before. Okay, so basically cross product is same as finding determinant. Okay, so there's a difference between, you can see that cross product as compared to dot product. So in a way, dot product is actually is easier because it's quite straightforward. Okay, but for cross product, all right, so you have to show this method. So in exam, this method got marks, so you must actually show this. So the setup here also got marks. All right, this method also got marks, and then also, of course, the final answer has marks. Okay, so basically you have to show all this. Okay, procedure. Okay, all right, and then of course the note down here basically is what I've mentioned earlier. All right, that the cross product is defined only for vectors in three-dimensional space. Okay, but dot product is defined for vectors in two space or three-dimensional space, and cross product is actually is a vector. Cross product of two vectors is a vector, whereas dot product is actually is a scalar number. Okay, so let's look at maybe first example. All right, finding cross product. All right, okay. So let's do this. So let's say now you are given two vectors, all right, vectors, vector u and vector v. So vector u has that component 1, 2, 3, and vector v has component 4, 5, 6. So then when you want to find its cross product, so you cross v. Okay, so again the setup, all right, the first row is your vector or unit vector ijk. All right, and then the second row will be component for u. So component for u is 1, 2, 3. And then the last row will be component for vector v. So in this case is 4, 5, 6. Okay, so then, all right, you have your plus I, positive I, okay, followed by determinant of, okay, you have your determinant of your 2 by 2 later on, but this is positive I. Yeah, I'm writing this one first. Positive I minus, and then I will have my 2 by 2, and then minus j, and then plus another determinant for 2 by 2, and then my vector k. Okay, so it will be positive I minus j plus k. Okay, so what's inside? Okay, for the first one, the component for vector I, all right, the minor would be you cover or you delete your I column. So if you delete your I column, so you are left with 2, 3, 5, 6. So then it will be your 2, 3, 5, 6. Okay, and then for j vector, determinant for j, you then delete the j column. So you delete the j column here. Okay, then you are left with 1, 3, 4, 6. So it will be 1, 3, 4, 6. And then for the last one, you cover your k column. So then you will have your 1, 2, 4, 5. Okay, so then only after that, find your 2 by 2 determinant correctly. So you multiply the main diagonal. Okay, so perhaps this one I'm going to write step by step. Okay, so in a bracket, it will be 2 times 6, and then minus 3 times 5. This is for the I. Okay, and then followed by, for the j, it will be, okay, minus, and then in a bracket, so 1 times 6 minus 3 times 4. This is for the j. All right, and then followed by, so in a bracket, so 1 times 5, okay, minus 2 times 4 or 4 times 2. This is for the vector k. So this is your 2 by 2, all right, determinant. Okay, so then make sure you compute correctly. All right, for I, it will be your 2 times 6, 12. 12 minus 15. So 12 minus 15 is minus 3i. Okay, followed by minus. Alright. Then what you have is actually in the bracket, you have your 6 minus 12. Okay, so that is negative. So just put your negative first. So you have your minus 6j and then plus, okay, and then you have your 5 minus 8. So again, another negative here, 5 minus 8, so minus 3k. Then finally, what you have is minus 3i plus 6j minus 3k. So until here is full mark if everything is correct. Okay, but I just want to write the last component. Either you write like in terms of ijk, our standard basis, or you can also write in terms of this, also can. Okay, you can write in terms of that component of a vector, also can. Okay, but basically, as I said, the last step here, the last answer is optional. Okay, until here, until your minus 3i plus 6j minus 3k, that is actually is enough. So the last one is actually optional, but I just want to write. Okay, all right. So again, this is your cross product u cross v. So your u cross v is actually is a vector. So when it is a vector, the direction of a vector is given by this. This is actually is a direction. Minus 3 meaning to say, all right, you have your from the two vectors, all right, when you cross, okay, it will be going to the negative, all right, negative direction 3 units, all right, or you can say that this is in the direction of negative x-axis, this is in the direction of the positive y-axis, this is in the direction of the negative z-axis. Okay, so basically the vector is actually tells you in terms of direction. Okay, direction. So that is cross product. Any questions so far? So basically, this is not something new. This is not something new in terms of actually finding the cross product. However, just bear in mind that you have your vector, because this is about vectors. It's about multiplication of two vectors. So you have your vector ijk as your first row. Okay, so then your final answer also is in the form of your ijk or in terms of this last component. Okay, so that is cross product. All right, and then you have all this theorem in your textbook, in your module, okay, talking about these properties, okay, algebraic properties. Okay, you can go through all this in the book, okay, but perhaps I would like you to just highlight maybe one properties, all right, which is the first one. All right, the first one says that u cross v equals to minus v cross u, right? So that means, all right, u cross v is minus v cross u. So if question asks you to find u cross v, and if let's say you find, okay, u cross v basically, if I can show you, okay, because we are not you are not physically in class, if we are like face to face, I will show you how do we actually do the cross product from like two pens, right, like from two pens, and then let's say this, the first one here is the vector u, so this is vector v, another one, okay, and then when we say u cross v, we will put our hand on our vector u, and then we curl our fingers, all right, towards vector v. So the thumb pointing upward is actually is a cross product u cross v. However, if this is again u, this is v. If we say v cross u, our thumb is actually is pointing downward. That's why we have negative. Okay, that is where you have this negative sign here. Okay, you have this negative sign. So that means it's going downward. Okay, but I cannot actually show you. Alright, but later I will have a diagram to show you. Alright, this theorem. Okay, but another important geometric properties of the cross product that you might want to take note is actually is this part. Okay, this part also. Okay, all right, where it says that u, all right, u dot u cross v, okay, equals 0 if u cross v is orthogonal to u, and v dot u cross v equals 0 if u cross v is orthogonal to v. Okay, basically the cross product itself, okay, the cross product itself, it it is actually is orthogonal vectors to both u and v. Okay, it is actually is orthogonal vector because the fact that, okay, let's say this is your one vector, uh, one vector one vector u. So you have your one vector u, and then this is vector v. All right, so the cross product is the one pointing upward like this. This is our u cross v. So indeed, they are actually, this u cross v is actually is making 90 degrees to both vector v as well as vector u. Okay, all right. So they are actually orthogonal. That means this vector u here is perpendicular to u cross v, as well as this vector v also is perpendicular to u cross v. So which means if you dot, all right, you dot this vector v, you dot with vector u cross v, you will definitely get 0. Similarly, this u cross v, all right, you dot with vector u, you will also get it, you will see it will equal to 0. Okay, because the fact that, you know, u cross v is actually, they are orthogonal to both u and v. So then the dot product between u cross v and this v, as well as dot product of u cross v and this vector u equals to 0. Okay, all right, so that is actually is a similar concept from the dot product. Okay, this is the one. Okay, so this is actually is the diagram to show you what they call the right hand rule. Okay, all right, so but here we have a and b, but it's the same whether you say is u or v. So if you look at this diagram here, the first diagram here, they call it right hand rule, where you have your vector a, in this case is vector a, this is vector b. So the right hand rule says that, you know, for cross product, you put your hand on your vector a, and then your hand you curl, all right, towards your vector b. Okay, you curl your hand towards vector b. So your right thumb here is pointing to the direction of what we call cross product. So that is actually is a vector in the direction of this going up like that. Okay, however, if we say b cross a, all right, so this is where you have like the opposite direction. Okay, so the direction is actually is pointing downward. Okay, so that is using what we call the right hand rule. Okay, b cross a. All right, maybe I can just show you. This is just another example to prove. All right, to prove. All right, to prove this theorem. This is actually, this is from these two diagram. That's when the mathematician deduced the theorem just now. The properties, the first property just now, where we say u cross v. All right, where we say just now u cross v equals to the negative of v cross u. Okay, so the mathematician actually deduced this property from this principle. Okay, so let's just see the proof, all right, of this example. Okay, where this time using the same vector. Okay, using the same vector u and v in the previous example, find v cross u. Okay, so let's say now we want to find v cross u. Okay, look at our component just now, the previous example. Just one the component. Okay, so u is 1, 2, 3, v is 4, 5, 6. Okay, so u just now, all right, u is 1, 2, 3, and vector v is 4, 5, 6. All right, so now we want to see what do we get for v cross u. Okay, so again, you just need to set up correctly for v cross u. Okay, that means again, your first row is your ijk again, your unit vector ijk. All right, your second row is the component for v, because v comes first. Okay, v comes first here, so it will be V component for the second row. So that means 4, 5, 6. Okay, and the last component or the last row will be the component W. Oh, okay, sorry. Not W. It's supposed to be U. Sorry. Okay, so the last row will be component for U. So which means 1, 2, 3. Alright. Okay, if earlier theorem says just now earlier that U cross V equals minus V cross U. Alright. So earlier, alright, from the previous example, what we got is actually here. This is our U cross V. This is our U cross V. That means our U cross V is minus 3, 6, minus 3. Okay, minus 3, 6, minus 3. So U cross V just now, alright, we got minus 3, 6, minus 3. So which means you must be able to actually see that when we proceed our solution for this cross product, from here we must get what? 3 minus 6, 3. So that's what we should get for this one. Okay, so let's see whether we can get that answer. Okay, so then next step is now you start, all right, finding your determinant of 2 by 2. So for your positive I component, okay, or determinant for your positive I vector, you are going to find determinant of, okay, so you again delete your I column, okay, delete your vector I column. So that means you have your 5, 6, 2, 3. Okay, so 5, 6, 2, 3. So 5, 6, 2, 3. This is for I, okay, for I vector, okay, followed by minus. Okay, then cover your J column, So then your next 2 by 2 determinant will be 4, 6, 1, 3. So 4, 6, 1, 3. This is for the J. And then plus another one, last one, will be for the K. K vector. You cover the last column, column K. So then you have your 4, 5, 1, 2. Okay. So you have your 4, 5, 1, 2. So this is actually is the setup for the 2 by 2 determinant. Okay, where you select the first row, which is your IJK. Alright, so then now start to compute. Alright, start computing your 2 by 2 determinant. 5 times 3 minus 6 times 2. This is for the I, followed by minus. Okay, and then you have your 4 times 3 minus 6 times 1 for J, vector J, and then followed by plus. Okay, and then you have your 4 times 2 minus 5 times 1, K. Alright. Okay, so there down you can start compute this. Okay, 15 minus 12. So you got positive 3I. Okay, minus. Okay, then in the bracket you have your 12 minus 6. So that is positive. So which is then positive 6. So you have your 6J. Okay, and then plus. Alright. Then the last one. So you have your 8 minus 5, which is positive 3. Okay. Alright, so then if we compare just now, our answer for U cross V, you see your U cross V is minus 3, 6 minus 3. So then you look at this Okay, so that means this is actually is the same as, okay, this is actually is the final answer. You can just stop here, and then if everything is correct, it's correct. So I just want to show you that for the final answer is the same as minus. If you take out the 3 just now, you get your minus 3, right? 6 minus 3. So this is actually is the same as minus your u, all right, your u cross v. So you can go the other way around, all right. Okay, so this is just to show you the theorem just now. All right, okay, then we move on to the next one. Okay, there is a theorem, all right, because again, the fact that vectors u and vector v, they are non-parallel. Okay, they are non-parallel just now in terms of geometric illustration. For cross product is similar to dot product. That means you will have your one vector going like this. This is another vector v, where both initial point coincide. It's just that for cross product, okay, the cross product is actually is this vector. Okay, this is the vector for cross product. All right, but the fact that you have this vector u and v here, so therefore you are bound to actually have angle here in between. Okay, so that's why there's certain like theta comes in this theorem. Okay, however, for this theorem, okay, this is only to show you in terms of the magnitude of the cross product, because the fact that, all right, the fact that we said just now, okay, that because cross product is a product, sorry, cross product is a vector. So when cross product, okay, this cross product is a vector, so then it has direction, okay, which is given by the vector itself, and it has magnitude. So that means you can find its magnitude of this vector. You can find the length of this vector u cross v. Okay, because vector has direction as well as has magnitude. So that means you have a magnitude. So this is actually is a theorem, all right, to show you how do you actually find magnitude of a cross product using geometric illustration. Using geometric illustration means using diagram. So when it comes to diagram, there's angle. Okay, there is angle here. There is angle theta here. Okay, there is angle. Right. So this theorem is just to provide you with a theorem on finding magnitude of a cross product using geometric illustration. Because another way of finding magnitude of the cross product is just using our formula. Because remember, there's another formula. If you want to find, for example, you want to find magnitude of cross product, you can also using this, right? Whatever component plus, you can use this, all right? If this is from component, meaning to say, like this one, if this is our cross product, okay, if this is our cross product, is a vector. So if I ask you to find what is the length for this vector, what is the length for this vector, you are using this formula. Okay, you are using this formula to find the magnitude. All right, but this theorem, all right, the theorem down here is just a theorem, all right, which provide you with some sort of definition or formula to find magnitude of cross product from the geometric interpretation or geometric illustration. Okay, so then, all right, this is actually is the formula that the cross product, the magnitude of the cross product is the same as the magnitude of vector u, all right, times with magnitude of vector v times sine theta. Okay, so basically, actually, this one actually is gotten from using actually a concept of a parallelogram. Later, we will come back to this one as well. Okay, we will come back to this one as well. Okay, where they use a concept of parallelogram. They can actually extend this diagram into a parallelogram shape. Okay, all right, and then finding u cross v in terms of magnitude is the same like finding the height of the parallelogram. Okay, all right, so then you will have actually this Okay, so this is actually is just a theorem. Okay, there is one important definition here. Okay, one important definition down here. Talking about cross product equals 0. Okay, so the keyword here is actually is this parallel. Okay, definition says that if you have two non-zero vectors u and v, okay, two non-zero vectors, all right, u and v in R power 3, this R power 3, it means it's three-dimensional space. This is just a notation for three-dimensional space. Okay, so if you have two non-zero vectors u and v in three-dimensional space, so vector u and v are parallel if and only if u cross v equal 0. Okay, so u cross v equal 0. Okay, why is that? Because if u cross v, all right, equals 0, that means the vector u and v are parallel. Why is it? Because of, again, back to this sort of like definition also. Okay, it's actually a similar definition. Actually, definition for the cross product from geometric illustration is where you have something like u cross v equals to vector u times vector v. Alright, this is multiplication, sine theta. Actually, its definition is like this. Okay, so when sine theta, when theta actually equals 0, okay, when theta equals 0, so that means u cross v is actually equal 0. So when theta equals 0, you have this vector here. This is vector u and vector v. So imagine if your theta is 0, what will happen to your two vectors? So that means the two vectors, one vector u is here. So another vector v is also actually here on the same, right? Same vector. They are like overlap, coincide. That is where theta equal 0. Okay, so when they are overlap like that, so that means they are parallel. Okay, they are parallel. Okay, so when theta is 0, so then when this theta is 0 here, so you have sine 0 is 0, so that's when you have your u cross v is 0. Okay, so the important concept is actually is the word parallel for the cross product. So when the cross product equals 0, which means u and v are parallel, and it can actually go vice versa. That means the statement can go like this: u cross v equals 0 if and only if, all right, u and v, all right, u and v are parallel. They are parallel. Or you can say u and v are parallel vectors if and only if cross product equal 0. So this is actually is important concept, all right, when it comes to cross product. Now remember, in the dot product previously, for dot product last week, the important concept is about orthogonal. Okay, orthogonal vectors. So for cross product, okay, for cross product is about parallel. Okay, but for the dot product previously, for dot product, okay, you have your u and v are orthogonal. Okay, so for dot product, the important concept is about orthogonal vectors. Okay, or vector perpendicular. Okay, vector perpendicular means vector making 90 degrees in between two vectors. Angle equal 90 degrees. Okay, whereas for cross product, the important concept is actually is about parallel vectors in which the cross product equal 0. So if let's say, all right, depending on the question, if question say, all right, you are given u and v, for example, you are given two vectors u and v. Determine whether the two vectors are perpendicular or orthogonal. So if the word is orthogonal, you must show this, that dot product equal 0. If question say given u and v, and then determine whether two vectors are parallel. 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 So parallel means you show this. You show that the cross product equal 0. Or if they say that given two vectors, show that, alright, or determine whether two vectors are parallel or perpendicular or neither. That means you have to show both. You have to show both. You have to show cross product. You have to show dot product. Okay. So you have to. So that is actually is a very important concept. So you don't get mixed up. Okay, between the parallel and the orthogonal or perpendicular. Okay. Or another word, you must understand back in your head that if it's talking about cross product equals 0, that means vectors are parallel vectors. Vectors parallel means is this one. They actually coincide. Both vector coincide each other. They are like on the top of each other. That is parallel vectors for U and V. Okay, but for orthogonal means they're making 90 degrees in between. So you have your two vectors orthogonal. Okay, so orthogonal, the concept is dot product equals 0. Parallel is cross product equals 0. Okay, any questions so far? Okay, I'm not going to stop at 3 o'clock. I'm just going to finish off first. I finish off this section first because I don't have actually many slides to go. This is just a few more. All right, and after I finish, then I will give you 5 minutes break, and after the break, then only I will talk about final exam. Right? So we finish this section first, then only we'll take a break. Okay, I hope you all don't mind. I hope you all can bear with me. Okay. Okay, so any questions so far? So far, so good? All right. Can you all understand so far? So far, any questions? Any questions so far? All right. Okay. All right. Okay. So I proceed. Okay. So then the next one we will talk about area. Okay, finding area. In this case, if you look at this figure, it's about area of a parallelogram. All right. So you have actually encountered this before, right? If you remember when we deal with trigonometry last time, remember? Right? You have actually come across with a parallelogram figure, right? In which we said that how to find area of a parallelogram when we did our trigonometry before is where area of a parallelogram is basically is base times height. Okay, base times height last time. Okay, so you see this area for parallelogram is base times height. And that's why when we talk about area of a triangle, we cut into half our parallelogram, right? We cut into half our parallelogram, we will get our triangle. And so that's why our formula area of a triangle is half times base times height. Okay, half times base times height for area of a triangle. So we have actually we came across that during trigonometry. Now we come to the same thing also. Okay, it's a similar concept also. It's just that now we are talking about vectors. All right, using vectors to find area. All right, so when it comes to uh, finding area, all right, of this parallelogram, okay, parallelogram or even triangle. Okay, because triangle means you cut into half. Okay, so if you want to find area from two vectors, of course you will be dealing with the magnitude. Okay, we'll be dealing with the magnitude of that vectors, because if you want to find area, it will be dealing with the length of the diagram. Okay, we're talking about length, right? Length of the diagram. So that means if your diagram is actually originally is from a vector, so then if you want to find the length, it means is a magnitude of that vector, because magnitude of the vector will give you a number, a scalar number, because length, right, is a scalar number. Length is magnitude, okay, it's distance. So that is actually is a scalar number. So then it will be dealing with the magnitude of the vector. All right, so that's why you see that you have this actually. This is actually is from the theorem. Okay, in which to find area, all right, area of actually of a parallelogram, area of a parallelogram, all right, that has U and V as adjacent side, is actually given by this. Actually, the magnitude, okay, magnitude of the cross product is actually is area of a parallelogram. Okay, all right. So the magnitude, okay, so the magnitude of the cross product, all right, basically is actually is the area of a parallelogram. Okay, and that magnitude of the cross product, okay, this magnitude of the cross product, remember previously from here you have this theorem, okay, you have this theorem that the magnitude of cross product is given by this theorem, which is actually is the same as magnitude of u times magnitude of v times sine theta. So from this theorem, they deduce, all right, the area of a parallelogram. Okay. So basically, the proof, all right, the proving part is actually is from the geometrical illustration, okay, or this diagram basically, okay, where you have this is your vector. Let's say this is vector B, okay, this is vector A. All right, from this diagram, I'm just talking about labeling on this diagram. This is talking about vector A and vector B like this. All right. Okay, so basically, you have this is a vector B, this is vector A. So if you can actually extend, becomes a parallelogram shape. So to find area of a parallelogram, we said that it has to be base times height. So base times height. So in this case, base times altitude. Altitude means is the height. So base is this B vector. Okay. So if let's say we want to find the height, we want to find the height. Height is actually height for the parallelogram is this. This is the height. Okay, this is the height. All right, which has this makes 90 degrees. The height is here. This is the height. So if let's say this is your vector A, this is your vector B, sorry, this is vector B, this is vector A, and of course this is angle. So if you want to find this length here, you want to find this length, this height. So it's the same like your right angle triangle last time. You are looking at like right angle triangle. You have an angle here. This is your hypotenuse. This is your opposite. So isn't that, all right, opposite over hypotenuse is actually sine theta. Okay, so then this height is actually given by magnitude A times sine theta. It has to be magnitude because this is length. So if you want to find the length, the height is the length. So that's why you put a bar. You put bar here, all right, to denote magnitude. Okay? So you have your magnitude sine theta. Okay, so the height is magnitude A times sine theta. Base is magnitude of vector B. So that's why, all right, you will have, all right, area is actually is base. Base is vector B times height. Height is actually is given by magnitude vector A sine theta. So basically, all right, this is actually is the same as our A cross B or B cross A, doesn't matter. All right, it will be the same thing. Okay, because then what you have is actually is magnitude. So this is actually is magnitude. Okay, all right, because area is actually is a number. So then you must have this magnitude because then A cross B is a vector. So when you put your bar here, all right, which is magnitude, then it becomes a scalar number. Okay, because area is a number, is represented by a number. Okay, so that's why to find area of a parallelogram is actually this is actually area of a parallelogram. Okay, parallelogram. So it's actually is the magnitude of the cross product. Right? So if area of, so this is actually again back to here, this is area, all right, this one, this is area of a parallelogram. Okay, area of a parallelogram is given by magnitude of the cross product. Okay, cross product. U cross V or V cross U, it doesn't matter. Even though just now we said U cross V, V cross U is the opposite with the negative. Why? Even though it's negative, when you find the magnitude, you will get the same thing. Alright? Okay? Alright. So this is area of a parallelogram. So if you want to find area of a triangle, isn't that we said that area of a triangle is half of the area of a parallelogram, isn't it? So then area of a triangle is given by half times, alright, magnitude of the cross product. So you still have half there. Okay, so that is area of a triangle. Okay. Alright, so area is two-dimensional, parallelogram is two-dimensional. Okay, it's a two-dimensional diagram. Because later on, you will have also three-dimensional, alright, in which if two-dimensional is parallelogram, three-dimensional we call it a parallelepiped. Okay, it's a parallelepiped. So the parallelepiped is given by what we call a scalar triple product. So I will come to that. Okay, let's straight away do this example. Okay, let's do this example. Find the area of the parallelogram with two adjacent sides formed by vectors A and vector B. Okay, so if you come across this word, area of a parallelogram, so immediately you recall that it will be given as your magnitude of cross product. In this case, is A cross B. Okay, sometimes you will see when I write the magnitude, I'm using the double bar. Sometimes it's single bar. It doesn't matter. It's the same. Don't get confused. Alright? Single bar or double bar, it's the same thing. Okay, but what important is actually the moment you see is area of a parallelogram. So immediately you know that it will be magnitude of cross product. Okay, not just cross product is a magnitude of a cross product, because cross product itself is a vector. If you want to find area means finally it has to be a number. So it has to be magnitude of the cross product between two vectors. So in the question, you must be given two vectors. Okay, all right. Okay, so then find straight away your A cross B first. Then after that, we find our magnitude. So A cross B, again, your first row is your IJK. Second row is your 1, 2, 3. Last row is 4I, 5J plus 6K. Now, if you look at this number, this is exactly the same as the previous example I gave you, isn't it? Okay, because I just want to minimize the time, okay, to compute, because I hope by now you know how to find cross product, okay, to find this 3 by 3 determinant. So I'm using actually a similar example to this one, okay, this one, if you recall. If you look back at your example previously, the one that I've showed you, okay, I'm using this one, okay, this vector here. Because I just want to take straight away, straight away the answer here. Okay, so I do not want to go through again to compute. I just want this answer. So if you look at the answer we got just now is 3 minus 6, 3. Okay, 3 minus 6, 3. So that's what I want. Okay, so I hope by now you know how to find. So then just now we got this answer, which is 3 minus 6, right? We have got 3I minus 6J plus 3K. Okay, all right, this is what we got, isn't it? You got that here. Okay, 3I minus 6J plus 3K. Okay, so from this answer, this is the cross product. So now what you want, because you want your area. So therefore, area of the parallelogram is, okay, what you want is actually is this, given by magnitude of A cross B, which is the magnitude of your 3 minus 6, 3, right? Which is what? Square root of 3 squared plus minus 6 squared plus 3 squared. Okay? So then you use your calculator. 36 plus 9 plus 9, isn't it? 36 plus 50 plus 18. So then it's square root of 54. Okay, if you want to simplify, you can. If you want to leave the answer like this, also can. So then this is unit square because it's the area. Okay, so that means I hope by now you know how to find the cross product. So then if you want to find the area, you just extend one more step to find the magnitude.
Madam,
Yes,
madam, sorry to interrupt, madam. Just
yes,
want to ask,
yes,
the answer we
yes.
took from the 3 and negative 6 plus 3, isn't it from
Is it right answer?
the proven? No, I mean you took the answer, the 3
Which
negative
one?
6 plus 3.
Yeah. Oh,
Uh,
okay. Sorry. Oh, that one just now I wrongly look at. Oh, okay. Sorry.
yeah, I
Okay.
took the
It should,
opposite
okay.
one.
Okay, it should be this, right? Minus 3 plus 6 minus 3, right?
Yeah.
Okay. All right. Okay. Correct. That is the correct answer. Correct. Thank you, Jaya. All right. That's the correct answer. That means, okay, I look at just now V cross U, not U cross V, isn't it? Okay, but answer for the area is still the same, eh? Okay, so this one is actually is supposed to be minus, plus, and then minus. Okay. All right. Thank you. This is the correct one. So that means it's a minus. This is minus, and then this is plus. Okay, but actually the okay, but the answer for this one is still the same. Okay. All right. Okay. All right. Thank you, Jaya. So the cross product is actually is by right is this one. Okay, which is just now I wrongly look at the answer. I look at V cross U instead of U cross V. So what we want here is actually is A cross B is the same as U cross V just now. So it should be the answer for this determinant is minus 3I plus 6J minus 3K. Okay, but answer is still the same. All right. So that's why just now earlier, if you mention, I mentioned that whether it's magnitude A cross B or magnitude B cross A is actually is the same. All right. I mean, in terms of magnitude, it's the same. Okay, because the length. But of course, vector wise, it's not the same because the direction is different. But if you're talking about the length, the magnitude, the length is the same. Okay. All right. Okay. Thank you, Jaya. Okay, let's look at another example. Okay, this is also another example. This time is to find area of a triangle. Okay, this time is the triangle. Okay, but this time you are given 3 points. Okay, find the area of the triangle with vertices P, Q, and R. So, okay, let's let's say I want to just sketch, just sketch this. This is just a rough sketch. This is actually optional. You don't have to, but I just want to show you. Okay, if we want to sketch this, all right, this point on our three-dimensional coordinate system. Okay, remember we have our x, y, z. Okay, let's say this is x, y, and z. Okay, so this is just a rough sketch only. Let's say p is 1 minus 1 0. P from the origin, 1 unit means positive 1, assuming this is positive 1. And then minus 1, so that means go to the left 1 unit, and then 0 z. Okay, so that means nothing for the z, so that is my point P. Okay, all right. Q is again from the origin. Q is 2 1 minus 1. From the origin, go to the x-axis, positive axis, 2 unit, and then 1 unit to the right, positive y. So that means assuming this is the one. Okay, that is the point. And then -1, so that means go down 1 unit. So assuming that's the one, okay, this is just a rough sketch, that is Q, okay. And then the last one, R, from the origin, we have -1 for X, so that means we go to the opposite X axis, so we go to the back, all right, 1 unit, and then 1 unit to the right, Y axis, 1 unit, okay, and then 2 units up, okay. So that means assuming that is R. So that means, all right, we have, okay, then if we just draw a straight line, okay, we connect those points, so we have like a triangle, okay, so that's the triangle, okay, in space. All right, so we want area, but this time this is area of triangle, but what we have learned just now, that triangle, area of a triangle is half of area of a parallelogram. So that means we are using cross product, a concept of cross product between two vectors. Okay, so you have actually 3 points that connects a triangle. So you need to actually establish two vectors, all right, in which, all right, you must actually be able to find the cross product of those two vectors. Okay, now how do you establish those two vectors? First of all, you must understand how do you actually or how you must understand the geometric interpretation of cross product itself. The cross product itself, initially we said that we have a vector u, and then we have vector v. Same initial point, same initial point for both vectors. That is the concept of cross product. The two vectors are non-parallel, okay, and they have the same initial point. So they have the same initial point. So that is the most important concept for the cross product. Because when you want to establish two vectors from 3 points, so you must have this concept in mind. You must have this concept in mind. So you cannot just simply, all right, simply find any vectors, any two vectors. In your mind, this is actually the most important concept. So when you look at the triangle here, okay, all right, so that means one way to establish the cross product, all right, one way is perhaps if I can just draw another triangle, assuming that this is the triangle, again, the triangle here, PQR. Okay, maybe one possibility is you say this vector QR and this vector QP. That means you can say QP cross QR cross QP. This is one possibility. So that means, all right, that means you have this QR means this direction, arrow. QP means this direction, all right. They have same initial point. Okay, their initial point is they are the same, coincide. So this is one possibility. Now, but this is not the only one. Maybe you can also establish what? PQ. Maybe I draw in a different triangle. Okay, same PQR like this. Okay, maybe this time is like this, PQ and PR like that, with the same initial side there. Okay, so this one is vector PQ cross vector PR. Also can. All right. Or what else? Another possibility. Okay, for your PQR. You can say, oops. All right, you can say what? This is R, RP, and RQ. RP vector cross RQ. Also can. All right, and this is not the only possibilities. You have actually another 3 more. Another 3 more means it's actually is pointing opposite direction. If PR PQ cross PR, RP cross RQ, QR cross QP, these are all pointing, the cross product pointing up, pointing upward. Okay, pointing upward. Another 3 possibility is the one that pointing downward. Also can. All right, it's possible, because when it comes to area, like just now, all right, whether I use just now U cross V or V cross U, in terms of area, I will get the same area. So that's why, all right, when you want to establish your two cross product for this question, actually you have 6 possibilities, all right? But you must understand how do you actually establish the two cross product. Their product in terms of their vectors, their initial point must coincide. So you cannot just simply say like, okay, QR cross RP, cannot. Okay, if you say like vector QR cross vector RP, like this, okay, so cannot. This one doesn't make sense because QR, if I am referring to this diagram, or maybe if I draw again, you have these two vector here, okay, PQR. If we say QR means it's going like this. RP is going like this. That means their initial point not coincide. So this is actually is a wrong setup. It's a wrong setup for the cross product. Okay. So if questions gives you point, you have to be very careful. If question like earlier part gives you straight away two vectors, then that is straightforward. Okay, that is straightforward. You straight away cross. All right, like this one. Okay, you are given A cross A and B vector. You know that area of a parallelogram is magnitude of the cross product. So if one person do like this, A cross B, maybe another person, maybe they find in terms of B cross A. Can. So they will find B cross A and then they find magnitude. They will get the same answer. So it doesn't matter, B cross A or A cross B. Okay. However, if you are given point like this, you have to be very careful when you establish your cross product of the two vectors. So you must understand how you establish the two vectors, the two non-parallel vectors for the cross product. Okay, so then perhaps I'll just choose one. Okay, maybe I'll just pick one. Maybe I'll just pick this one, perhaps. All right. So you can pick any one. All right. So maybe I'll just pick PQ cross PR. Okay, so now we need to find, or now we have to find our component. Okay, our component for PQ vectors as well as our component for our PR vectors. Because then after that, we want to multiply using the cross product. Okay, so again, make sure you understand how do you find vectors from 2 points. Remember, terminal minus initial. So don't get mixed up. If you mixed up, then it's a different vector. Okay, so if you are unlucky, it's wrong. If you are lucky, perhaps it will be right. Okay, so again, back to this one, PQ. All right, so let's see PQ. Okay, look at the point P. P is 1, minus 1, 0. Q is 2, 1, minus 1. So now I want my PQ. So PQ. All right, so then 2 minus 1. All right, 2 minus 1 for the X component. For the Y component, 1 minus minus 1, which is 2. And then for the third component, minus 1, minus 0, so minus 1. So that is my component for PQ vector. All right, whereas for my PR, vector PR, okay, so now PR, PR, so you are looking at R and P, P and R. So again, for the first component, minus 1, minus 1. So that is minus 2. Okay, then for the second component, 1 minus 1, so that is positive 2. And then the third component, minus 1, minus 0. Sorry, 2. I'm looking at different one. 2, all right, minus 0, so that is 2. All right. So then, only now, PQ cross PR. So PQ cross PR, again, IJK, first row. All right, second row for PQ component, second row PQ component, 1, 2, minus 1. The last row is for the PR component, minus 2, 2, 2. Okay, compute this correctly. All right, So for the I, you cover the first column, so then it will be the minor 2 minus 1 to 2. That is for the 2 by 2 determinant for I. Minus, okay, 2 by 2 determinant, cover your J column. So 1 minus 1 minus 2, 2 for the minus J. And then plus, okay, the last one, you cover your K column. 1, 2, minus 2, 2 for K. Now, this step, you don't omit, don't omit this step because this one got marks during final exam. Okay, because if let's say your final answer for your vector product, that cross product, the vector is wrong, we will fall back on your method here. Because most likely you got here one, this one is correct. It's just that when you multiply then main diagonal minus another product, etc. So the tendency plus minus mistake is there. So that's why sometimes the final answer is wrong. But this step perhaps is right. So this one you got to show. Okay. Alright, so then only now the next step is to compute. Okay, so you can compute this. Alright, the last step here is actually is optional to show, like just now the step I showed you where I put like this 2 times 2 minus this part is optional. This part is optional. Okay, because the fact that you have calculator. So we know that you have calculator. You can actually compute. Okay, so that step, the one that I showed you earlier, step by step, that is optional. If you want to write, go ahead, no problem. It's good sometimes for some people so that it will ensure, all right, the correctness of your plus minus. But if you can do it top on of your head, do it. Or if you want to use calculator, straight away do it. Okay. So the last step straight away is actually is the answer. So then you can actually just compute this. Either you use calculator or you can just compute on top of your head. But again, don't make mistake of finding determinant. It has to be a multiplication or product of main diagonal first. Then only you subtract this product. Okay, so don't do it the other way around. If you do it the other way around, definitely it will be wrong. Okay, so then you have here 4 minus minus 2. Okay, so that is your 6, isn't it? So then is your 6i. Okay, and then minus. All right, then there's next one. You have minus here. Okay, you have 2 minus, this is positive, isn't it? So 2 minus 2, so that is 0. So j is 0. Okay, never mind, I'll just write. Okay, for the sake of writing only, but you don't have to write that. You can straight away omit the 0 if, all right, if you want. Okay, and then the last one, plus. Again, for the k, all right, so you have this 2, k minus, minus 4. So that is another 6. So that means you have your 606, or you can say 6i plus 6k also can, right? But what you want is actually area of a triangle, right? Okay, so just now is the area of a triangle. So area of a triangle, all right, area of a triangle, PQR is given by half. Okay, don't forget half because this is triangle of magnitude of the cross product. Okay, which is then half times square root of 6 square plus 6 square. So that means it is actually is just half 72, or if you want to simplify, can. All right, because then 72 is your 36 times 2, right? So 36 is 6, so you can say 6 over 2, so you can write as 3 sec 2. If you want to simplify, go ahead, all right? But if you leave your answer with this half square root, this one still correct. This until here is already full mark already. Okay, this is actually optional. Until here is already full mark. All right. Okay, the last one. This is now the last one before the break. Okay, this is area of a triangle. Okay, this is the one that I mentioned about the volume of a paralleloid. Okay, because the fact that this is also can be drawn in terms of the three-dimensional. Okay, because vector product or cross product is actually is a three-dimensional space vector. So you can have a three-dimensional diagram also. So if two-dimensional is parallelogram, so three-dimensional we call it a parallelepiped. Okay, parallelepiped. That is a three-dimensional for two-dimensional parallelogram. It's the same like your cube. Two-dimensional is a cube. So three-dimensional you call it what? Cuboid. Okay, so you have that. All right, like two-dimensional circle. Circle is two-dimensional. Three-dimensional is sphere. Right, sphere. So parallelepiped is a three-dimensional for the two-dimensional parallelogram. So if it's a three-dimensional, you find volume. Two-dimensional, you find area or surface area. For some, if let's say like circle, sphere, we call it surface area. Right? You can find surface area of a three-dimensional. Like cuboid, parallelepiped also, you can find surface area. You don't find area, it's a surface area. But two-dimensional, you say area. Okay? But for this one, all right, because you have this what we call scalar triple product concept. So that scalar triple product concept, all right, where it combines dot and cross product together, and the magnitude of that is actually the formula for the volume of the parallelepiped. Okay, parallelepiped. Okay, so this is actually is just to find volume. So if magnitude of a cross product is to find area of a parallelogram, the mixed dot and cross like this, or we call it scalar triple product, is actually is the formula of volume. Volume. And for this, all right, for this scalar triple product, you need three vectors. You need three vectors. All right. And those three vectors again, they are all initial value, initial point are all coincide. Okay. 3 points, 3 initial point coincide. Okay, initial point for three vectors are coincide, and those three vectors are non-parallel vectors. Okay, they call it non-coplanar because coplanar is actually referred to the three-dimensional. Okay, three-dimensional we have a plane, we have several planes, so we call it coplanar, non-coplanar. Okay, non-coplanar. Okay, so they are non-coplanar means they are the initial is on the same. Okay, they coincide initial point, and they are non-coplanar. All right. Okay. All right. So let me just straight away do the example because this is actually is the last one. Okay, you have a similar example in the book. But for volume, for parallelepiped, you must be given three vectors. Okay, three vectors must be given. In this case, is U, V, and W. Okay, it's just that in terms of setting up the scalar triple product, they call it scalar triple product because it involves both a dot product and dot product as well as cross product, but the final answer is a scalar number. That's why they call scalar triple product. Okay, scalar because the final answer must be a number because this is volume. Volume must be a number like area. It has to be a number. Okay, and they just call triple product triple just because of three vectors. Okay, all right. So then they call it scalar triple product. So the setting up of the formula is something like this. You have three vectors U, V, W. So you will have U dot and then V cross W, or it can be V dot U cross W, or it can be W dot with U cross V. Or you can also have, instead of U cross V here, it can be V cross U. So actually it doesn't matter how you set up. Okay, it doesn't matter. All right, as long as you must have this one, you must have this dot, and you must carry out this first. You must carry out the cross product first. Because why? Because you are going to do a dot product. So this is vector. So you can only dot vector and vector. Okay, vector and vector. So that's why you must settle this first, the cross product first. Then only finally you dot. Then only lastly you got your scalar number. Okay, so that is actually is about this scalar triple product. And when it comes to volume, okay, when it comes to volume, that means, all right, it involves with magnitude. Because, all right, why? Okay, why must we have that magnitude? In fact, when we dot, right, we already got our scalar number, isn't it? It's already scalar number. So why need this magnitude? Okay, for scalar triple product for volume, this magnitude representation here can also be referred as like your absolute value. When I say absolute value means because scalar number can be also negative, right? Your scalar can also be negative. So when you have this symbol representation, any negative number becomes positive, isn't it? Okay, so that for scalar triple product for volume of a parallel pipe, this symbol can also refer as like absolute value to take care of any negative number inside, because you want volume. So volume, you cannot have negative number. Like area, you cannot have negative number for the area. Okay, all right. So let's do this. Okay, so let's say I'm selecting the first one, like u dot, okay, vector u dot v cross w. Okay, so you can also choose others, as I said, v dot u cross w, w dot u cross v, it doesn't matter. Okay, so if I do that, that means I need to find my v cross w first. Then only finally I dot with the u. So this is what we have to find first. Again, ijk, all right. V is 456, W 780, because there is no K there. Okay, W is 7I plus 8J, that means 0 for K. Alright, so again, as I said, the first step here is a mass. Alright, 5680I minus, okay, and then 4670J plus 4578K. This step is a must for any cross product because there's a mark there. Okay, the last step, the one that just now I mentioned, you can straight away jump to the answer because you can use calculator or you can just do it on top of your head. Okay. All right. So then, if I straight away find the determinant 2 by 2, again, don't forget 5 times 0 minus 8 times 6. So it goes that way. All right. Okay. So then 5 times 0, 0, 0 minus 8 times 6. So that is minus, make sure it's correct, plus minus. Minus 48I followed by minus. Okay. Again, 4 times 0 and then a minus 7 times 6. So that is another minus there. Okay. And then plus, and then 4 times 8. Alright, 4 times 8, 32 minus 7 times 5 minus 35. So 32 minus 35, so another minus then. That means your final answer is your minus 48, positive 42, and minus 3. That is your V cross W. Okay, then only, okay, you just need to ignore this because they appear another similar question. Okay, I just need the blank space. Okay, so that is our V cross W. Okay, vector minus 48, 42, and minus 3. So finally, what we want is U dot with V cross W. Okay. Alright, our U is our, okay, maybe I can just refer here. It's the same thing. Our U is actually our vector 1, 2, 3. That is our vector U. Now dot with our vector V cross W just now, that minus 48, 42, and minus 3. Okay, then dot product is 1 times minus 48 plus 2 times 42 plus 3 times minus 3. Okay, use your calculator now. Okay, I'll get 27. In this case, it's just so happen it's positive. Okay, so therefore, I can say my volume is All right, it's a magnitude of U dot, okay, V cross W. This is volume of a parallelopipe, which is just so happen is positive. Unit cube. Okay, that's all. 1 hour 40 minutes. Okay. Do you need a break? Or you want me to just continue with the final exam? Okay, your final exam is until here. Okay, final exam is until here. Can you all understand lecture today?
Yes, madam.
All right. Anything which is not clear? Or anything people would like to ask? All right. Okay. Any question? Any question for today's lesson? Any question for this cross product? Anyway. Any question for for cross product? I hope everybody understood this. All right. Okay. Anyhow, I'm going to oh, did I record this one just now? I think I record, eh? I hope I recorded. I forgot. Okay, but anyway, if you think you can still bear with me, maybe I can just straight away talk about final exam, or do you need a break? After all, it's already like 3:40. Or can I proceed with the final exam? Can? Sure. All right. Okay. All right. So again, final exam is until here. All right, for your vector. So that means this is the end of our lesson. Okay, our lecture. All right. Let me talk about final exam. I hope. I do not know whether have everybody got their exam slip? Has everyone got their exam slip? Yeah. Yes or no? Exam slip. Has anyone obtained their exam slip? Maybe your exam slip is where? How did you get? How to get your exam slip? Do you know?
Yes, madam. SMP.
How? Oh, SMP. Okay, SMP. All right. Okay. So those who haven't obtained, maybe later on you retrieve from your SMP your exam slip. Okay. I suppose in the exam slip it will give you the link for the final exam portal. Okay. Our exam portal basically, I suppose, is similar to ULearn. Okay. I do not know because this is our first time. Our first time having online final exam, because last semester our faculty did not have a final exam online. Okay, what we had previous semester was what they call final assessment, not the final exam. So this is the first time this faculty is holding a final exam, online final exam. So I do not know about the portal, but all I know is that the portal, exam portal, is similar to the ULearn portal. Okay, because I'm not the coordinator, so that's why I do not know about this portal, because I don't upload question. Okay, only the coordinator will have to upload the question. Okay, so you will have the link. You are given that link. The link is provided in the SMP. So make sure everyone has their exam slip. Okay, afterwards. Okay, look at your SMP. You look at the exam slip. So that is where you can actually follow the link for the exam, final exam. Okay, so if when they say that the portal is similar to ULearn, that means you are going to go into that link. All right, on the 28th. Okay, our paper is on the 28th of January. All right, 28th of January. 9 o'clock. Okay, so 9 o'clock in the morning. All right, so make sure you are in front of your computer. Maybe give yourself like maybe like half an hour before, you're already there in front of your laptop or whatever. Okay, all right. And make sure that I think by 9 o'clock you can straight away go to that link. All right, and retrieve the final exam question. Maybe I'm not sure, I'm not so sure. Maybe it is similar to like when you had your mid semester test last time. Okay, I think so. All right, so you go to that link, you click, maybe you just need to follow the instruction, whatever. Okay, so they will straight away go to the subject. All right, then you can maybe download. Okay, you download your question. All right, so you download your question and you are going to do it in 2.5 hours. Okay, let me just okay, I have this instruction where I'm also going to oh no, I've already uploaded into the ULearn. Later on you can actually get this instruction also. All right, if you can look at the screen. Okay, so this is our time, our date and time. All right, 28th of January on Thursday, 9 o'clock in the morning until 11:30. It's a 2 hours and 30 minutes exam. Okay, there's a venue here somehow, even though it's online, there's a venue. So maybe when you log into that portal, you go to the portal, I think they will assist you where to go. You just need to click maybe hall 1, hall 2, I'm not so sure. Maybe you will find out this one later. Okay, this is what you want, I think, the format of our final exam. Okay, so this is the format. Okay, so listen carefully, look at this carefully. You will have two parts, all right, part A and part B. So part A basically is the compulsory question answer all. So you'll be given 3 questions for part A. So answer all. So it's a compulsory question where question 1 consists of a mix between chapter 2, analytic trigonometry, as well as chapter 5, our vector. So it's a mixed question for question 1. Question 2 is coming from chapter 4, which is complex number, and question 3 is from this again vector. All right, chapter 5. All right, and for part B is a choice question where you are given 2 questions, but you just choose to answer one. Okay, you just need to answer one, but both questions are coming from application of trigonometry. So that means you need to answer one application of trigonometry. All right. Okay, and the fact that altogether are 4 questions, so that means each question consists of 25 marks each. Okay, so each question worth 25 marks. So that means total will be 100 marks. Okay, for your final exam question. All right. Now, because this is question for question 4 and 5, this is a choice question. So our suggestion is you just need to choose one. Okay, don't do 2 questions. Okay, don't do both. Don't do both. Okay, maybe previously, I think during maybe school days, I'm not so sure, maybe SPM or whatever, even if there's a choice, you can actually answer all and then they will choose the best one. That is during school days or perhaps previous institution. But here, we are not going to do that. We are not going to like mark all and choose the best one. No. Even though it's like 4 and 5 is similar, it's a application. So you just choose one and do. Okay? All right? And then, okay, make sure your calculator, your stationery, and answer sheets are all ready beforehand. Don't like in 30 minutes you're going to have your final exam, then only you find your this and that, prepare for answer sheets, etc., etc. No, please make everything ready. Be ready, okay? Make everything ready beforehand, okay? And there is no appendix given, so that means this is an open book exam. You can actually look at the formulas, all right, in your textbook. Open book exam, so it's up to you. Okay, basically it's an open book exam. So that means if you need the necessary formula, just look at them. And I would suggest, remember that textbook has the appendix for the previous your textbook here got appendix, because the review exercises in the textbook at the back, there are 7 review exercises. Basically, these are all past years. These are all past years. And the last page on page 271, there's an appendix given in final exam. Maybe I would suggest you just refer straight away to this because they compile all formulas there. So you don't need to like check, page by page to find certain formula. You just look at those appendix. Okay, that is my suggestion. But anyway, it's up to you. All right. And even though it's 2 hours and 30 minutes, all right, this time for final exam, you are given additional 30 minutes for you to upload. Okay, 30 minutes for you to upload. Not like last time, midterm test, last time we said 1.5 hours, including the uploading time. But this one, no. 2.5 hours is solely for you to answer. Okay, 2 hours 30 minutes is solely for you to answer. All right, to write your solution. Then by the time 11:30, maybe I think coordinator will remind everybody. I think so. All right, they will remind you to start uploading. Okay, they will remind you to start uploading. Okay, maybe I also can remind you at 11:30. I'll just message into the WhatsApp, start uploading. But of course, if you don't look at your handphone, then of course you cannot see lah. You do not know. All right, but 11:30, you make sure you start upload your solution. Okay. Now it is similar to test where it is your own paper. All right, you make ready with your own answer sheets. Your so make sure again similar. Okay, we put the similar instruction. Similar instruction. For test question last time. Okay, writing should be legible. All right, the answer to a new question should start on a new page. Using pencil is not allowed. Make sure your name, student metric number are written on every page of your solution papers. This is a must. Okay, this is a must. Name and student metric number. So that's why a night before your final exam, you already write already your name and metric number to all pages, right, of your solution papers. Okay, so you can actually ready beforehand all this. All right, don't wait till last minute. Okay, don't wait until the moment you want to upload, then only you write your name and your metric number. So you lose time, all right? Okay, so it is your responsibility to ensure that you submit your solution by uploading it into the online exam portal. So I think it will be the same. It's same like your ULearn where you retrieve you download your question, and then that is the place also where you upload. Okay, you upload your answer. And it has to be in PDF. Okay, it has to be in PDF also. And you must have cover page. Later I'll show you. There's a cover page that I need you to all download from ULearn as well. Okay, all right. And then you have to upload before 12 o'clock because your exam is until 11:30. So make sure you're given half an hour, all right, to upload. So you must make sure you upload successfully before 12 o'clock. So even though you may see this is like additional 30 minutes, so that means maybe some of you, maybe by 11:30 you have not finished. So you think of like using that time to still write your answer. Okay, but bear in mind, you are not the only one that need that uploading, all right, into the system. There will be hundreds and hundreds, maybe I do not know, maybe it could be like 1,000 students are going to upload because your paper itself is taken by both faculty, okay, FTKEE and FTKMP. And beside that, there will be other students from other faculty are also taking final exam at the same time. Okay, same time from other faculty. So they are also taking the same time. It's the same time. So they need to upload also to the system. So you imagine if you wait, all right, if you wait, so if let's say by 12 o'clock, your uploading is not successfully, then I'm afraid that I'm afraid that you may get zero because you don't submit. Because this time final exam is administered by BPA. BPA is our bahagian pengurusan akademik. It's an academic unit, okay, academic division of the university. Not me, not us, not lecturers. Because this is final exam, is official. Like mid semester test, all right, assignment. That is us who actually controls everything. We are the one that set up this and that. All right. That's why we use ULearn, things like that. But now because it's a final exam, it's administered by the university, okay, academic unit, so it's all from them. So they are the one that actually administer your final exam. Okay, they are the one that make sure that by 12 o'clock they shut down or they disable or they lock the system where you cannot actually upload. So it's very important that you use the 30 minutes to upload. Okay, so make sure you use your time 2.5 hours all right, to really answer the question carefully and then correctly, all right, use that time. Okay, so then by 11:30 start uploading. By 11:30 make sure you compile everything, all right, your answer scheme, answer sheets together with your cover page, in front. all right, you maybe you use cam scanner, whatever, all right, into PDF, and then upload everything correctly. Make sure pages also, if possible, each page also you put a page number. That will be much easier for me as well. Like test and even assignment, just for information, I do receive like some suddenly, they jump, answer jump. Okay, from this question then jump to other question, then I have to like search for it, but it's okay because like test and assignment, okay, I have ample time to do that. I can use like even 1 month to mark if I want to. Okay, but like final exam, we don't have much time. We are given only like 1 week to mark. So that's why it is very important that you do it everything correctly. That means pages don't mix up. Don't make sure I don't lose or you don't lose pages. All right, for your solution. Okay, and also make sure also you follow this time correctly the instruction to naming your file. Okay, your document. So this time I need to highlight again. FE is for the final exam, followed by your program, followed by your section, then only followed by your name. So I do not want to receive like suddenly the name of the file is final exam, final, like that. Similar to assignment, even assignment 3 also I still got assignment 3, like that. Even though we said A3 underscore BEET underscore, etc. etc. But still, assignment 3, A3. A3, okay. Assignment 3, assignment. That's all. There's no program, no section. The worst case is no name. Okay, then I have to like click and find out, this assignment belongs to whom. Then I rename your file. Okay, because I want to make it easy on my side. So that's why then I have to rename your file. That's what I did for your test as well as your assignment. So I really hope for final exam I do not have to do that anymore. Okay, because if you follow the instruction carefully, I do not have to actually rename your file. Okay, because time is precious for final exam for both you and me as well. All right, so I need to make sure I can mark within like a week. Okay, so that because that is the time that is given for us. Okay, all right, in case you use a lot of pages to answer. Okay, they mentioned here that the maximum size for each file is only 10 megabyte. I do not know this 10 megabyte refers to how many pages. I'm not so sure. In PDF, right? In PDF, I think maybe it's a small size, right? Once you compress into PDF, the size maybe is small, but I'm not so sure. All right, but in case you use a lot of pages, suddenly the size is bigger than 10 megabyte, then what you need to do, you break it up because you can upload more than once. Okay, so here they put unlimited numbers because they just want to make sure that you upload. Okay, they put here because they want to make sure that you are able to upload. Maybe because I think the exam unit, the academic unit thought that perhaps during final exam, because there are so many people trying to upload at the same time, so in case that you try to upload once and then it doesn't successful, so you can try again and again and again. Maybe that's the reason why. Okay, and another thing is if let's say the size is more than 10 megabytes, then you break it up. Okay, you can break it up. All right, all right. Okay. Do not forget to attach final exam, final cover page, final exam cover page. Okay, this one I've already actually uploaded into the ULearn. You can check under week 15. ULearn week 15. ULearn week 15 actually is an additional week that I put. That's why you will see week 15 there is no logo. Okay, well for week 15 because the one that is actually prepared by the PSTP department is only until week 14. Okay, so but I'm using like this week is week 15, so I have to have additional week 15, so I add another week, so that's why I don't have the logo. Okay, but under week 15 you will see that I've already uploaded this instruction as well. I already uploaded the cover page for final exam, so please download it. All right, download it. Download it, and then later for final exam use it as a cover page, in the front of your paper. Okay, and again, make sure, all right, make sure you write your name, matric number, program, etc. properly on the test cover page. All right, maybe I can just show you the cover page. Cover page. This is the cover page. Okay, this is the cover page. All right. Now the cover page. What is the most important? The cover page is actually this. Your name. Okay, your matric number. And then make sure circle your program. If you are BEET, you circle BEET. And if you belong to 2/1, circle 2/1. Okay, and write down, of course, my name. All right, down there. And this one is for me to write, so just leave it blank. All right. Okay, so this is the cover page. I've already uploaded into the ULearn. All right, and you just need to make sure that you download it. All right, you download it and then use it. Okay, during final exam. Okay, final exam day. Okay, so this is that is for our paper, for our technical mathematics. Okay. All right. Any questions? So it's already 4 o'clock. Non-stop for 2 hours today. Okay, we will still have, yes.
Sorry.
It's
So
okay,
it's like other universities, they're using some kind of application, is it? It's called Safe Browser. So it's like once you enter the Safe Browser, you cannot access to other things. Is it our university still using the same thing, or is
Okay,
it yeah?
Kaushan, if you ask me, I really do not know. I'm sorry. I'm sorry. I have actually no idea about that. Whether our university is using that or not, I'm not so sure, because as I mentioned, like the exam portal itself is actually, this is the first time our faculty is actually having final exam. So I'm not so sure. When you say a browser, what do you mean? Is it for what?
It's like a browser. It's like a Google Chrome also, but it's like once you enter to the it's like once we enter to the test, so you cannot back task. Is it? It's like you cannot access to other application or what? So it's like fixed once until the exam finishes. So once you enter, it's like you are locked there.
I'm not so sure. I'm not so sure about that, Kaushan. I'm so sorry. I'm so sorry.
It's okay, madam.
But
Just asking.
yeah, okay. Thank you very much for asking. But again, I'm not so sure, because after all, you need to write down your solution. You are not writing anything on the computer for mathematics, right? So I'm not so sure on that note. Okay, because you just need to download the question like your test that time. Okay, maybe you download the question, and then maybe the question you just read from the computer, perhaps your laptop, okay, or your PC. All right, you just need to read the question, but your answer, your solution, you have to write down on your paper. Right, and then once you finish, you just need to what? You take a photo, right? Like it, right? Or you use your phone for the cam scanner, straight away change to what, in PDF, right? Like you scan your solution, right? In a way, it's like you got to scan your solution actually, because it has to be in PDF. So you scan your solution, then you just need to upload. Make sure that everything is inside your PC again for you to upload. So then I'm not so sure, like you mentioned just now, in terms of what browser our university is using or whatever. I'm not so sure about that. But my thinking was like the portal that is about if it's about a portal, I'm thinking it's a portal is maybe perhaps is similar to ULearn. Okay. But again, I'm not so sure, because because this is our first experience for final exam online this semester. Last semester we don't have final exam online. Only the engineering faculty, they have final exam, but for the engineering technology, ours is the engineering technology. Engineering technology last semester, it was a final assessment. They call it final assessment, where students were given like question to be answered within a specified time frame, certain duration. Then after that, people submit like some sort of assignment type, but maybe but the question may be like harder, because you are given some time, ample time to do it, and then you submit. So something like that. That is what happened last semester for engineering technology. But engineering faculty, they already had exam exam online last semester, but this time all faculty have online final exam. So that's why I have no idea about what is going to happen during that time in terms of like portal, how I know you learn, but I do not know this exam portal because I'm not a coordinator anyway. So I have no idea. But as I said, my guess is similar to you learn. But in terms of browser wise, I'm not so sure. Right, Kaushan? So sorry.
Yeah, it's okay, madam. Thank
Alright.
you, anyways.
Okay. Okay.
Madam?
But anyway, any other question?
Yes. Madam, when are we going to get our carry mark?
Actually, it's already there for 50. Sorry, 50% is already there because I've already key in your assignment too. Okay, but it's just that I asked actually that time. They told me that somehow I'm not so sure, but somehow they told me that yes, indeed, student only could see their carry mark until week 12. Then after that, student did not get to see their carry mark. Okay, but I do not want to argue lah with those people. But what I'm thinking is that, okay, my planning is I am now still marking your assignment 3. I'm in the midst of marking assignment 3. So once I've done that, once I finish marking assignment 3, and once I have key in assignment 3, I am going to actually share, or I'm going to post your 60% coursework later. Maybe either I upload it into the ULearn, or maybe I'll just perhaps send through WhatsApp. I'll see about that. Okay, but I will actually share with you. Okay, I will reveal. In a way, I will reveal your 60% coursework mark. Anyway, that is your marks. It's not confidential. That 60 mark is not confidential. Okay, so I will do that. Maybe I'll try by maybe next week or before your final exam. Okay, because I'm still marking the assignment 3. Okay, all right.
Right, madam.
Okay, welcome. Any more question? We will still have a session on Thursday. Yes, okay. Yes, okay.
The actual final marks for the final exam is 40%, right?
Yes.
Okay, madam.
That's why. If you know your 60%, okay, so that's why if you know your 60% carry marks, actually is you know your standing already, okay? And you can actually fairly have some idea how's your final marks, right? Final marks will be, or final grade will be. You can actually have some idea because after your final exam is over, all right, you can actually in a way like you can mark your own self lah. You can mark your own papers, isn't it? Because this is soft copy. You will have a copy of yours, right? Solution. Of course, once you submit it, you still have a copy, and you can discuss with your friends. You can try to mark yourself, give yourself some marks, for your answers. You can do that. So you can have like rough idea your exam, your final exam marks actually. So with that 60% of your carry marks, okay, your coursework marks, then you have actually some sort like an idea, all right, your grade for this paper will be. So that's why I am going to reveal that 60% after I finish marking assignment 3 and after I've keyed in. Okay, and I hope to do that by next week, inshallah. Okay, before your final exam, okay, on the 28th. All right.
Okay, madam. Thank you, madam.
Okay, Haziq. Okay, welcome. Okay, as I was about to mention just now that we will still have our session on Thursday because that will be our last session for the semester. All right. So perhaps this coming Thursday, what we are going to do, we are going to just maybe again I don't think that we are able to do all questions in for your chapter 5. Okay, but at least we can go through quickly like what we did last week. Okay, we go through all right. So perhaps the one that you think that is difficult, that you need more clarification, or you want to see the working, maybe I can show you. Okay, but the one that perhaps is very quite straightforward, all right, we can just you can do it yourself. Okay, I don't have to show you. So we can do that quickly on Thursday session, and plus with perhaps any other question that you might want to ask. And again, for vectors as like complex number, it's not difficult because basically it is just a computation. All right, just make sure that you don't make any careless mistake in your computation. Make sure again, like I mentioned, it's like complex number. Certain question maybe is a bit lengthy. In terms of solution, it will be long. But again, make sure you have a patience and passion to do it. All right, and the most important, don't make careless mistake. Okay. All right. So if there's no more question, perhaps we can end the session now. It's already like 10 minutes past 4. Sorry for that. Today is like non-stop. All right. No break. Okay, in between. All right. We can end the session now if there's no more question, and we will meet for the last time on Thursday morning. Perhaps everybody will join in just in morning session. Okay, for group my afternoon session also for those who are in the afternoon session, you join in again for morning session for the last time. Okay, for this coming Thursday. Will that be okay? All right. All right. Okay, everyone.
Okay, madam.
Okay.
Okay, madam.
Okay, all right, thank you. All right.
Thank you so much, madam.
You're welcome.
Thank you, madam.
Okay, welcome.
Thank you, madam.
So,
Thank you, madam.
bye.
Thank you, madam. Terima kasih.
Okay, Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, madam. Assalamualaikum.
Waalaikumsalam.
Thank you, madam.
Okay, welcome.
Thank you, madam.
Okay, welcome.